I'm sharing my screen. Write the letter. What are the lengths of sides of this equilateral triangle? Is that right?
Yes, please.
Okay, great. So the fact that it's an equilateral triangle means that all the sides are the same. So you just have to set two of the three sides equal. It doesn't really matter which ones. Let's set 4x equal to 3x plus 5. If you solve this, if you subtract 3x from both sides, you end up getting x equals 5. But this is not the answer. This is the intermediate answer. So the answer is putting x back in. So a side is like 4 times x, which is 4 times 5. So the answer is 20. Is that good? Is that okay?
Yeah.
Great. All right. So we can start getting into a rhythm here too. Okay, so we got to classify the triangle based on its sides. The most direct way to do this is to find the distance between each of the sides. So, like, what is the distance from A to B, B to C, and C to A? Because this one
Mhm.
has nice vertices, like here's 0, 0, 4, 3 is here, 4, -3 is here. You could maybe get away with drawing a picture and figuring out what it is without doing the calculations. Um,
Mhm.
like I can tell you that this is isosceles. These are the same length, but this one's longer.
Mhm.
If you didn't know that, you would have to use the distance formula: x2 minus x1 squared plus y2 minus y1 squared square rooted. And you'd have to do that for each of the A, B, B, C, and CA.
Mhm.
This one worked out really nicely, so I'm not sure what to suggest because it may or may not be like that on the actual test.
Yeah.
Do you remember if your instructor gave you Form 2A last time for the exam, or did they give you, uh, 3A?
I don't remember.
Okay. All right. So number 3, what is the measure of angle 1? I'll snip that picture in. All right, so angle 1 is over here, and you can tell me this angle that I'm pointing at with the arrow there because these are on a straight line. I mentioned
Mhm.
before that typically they either add up to something,
Yeah.
some number, or they're equal. In this case, the one I'm pointing at in 120, they add up to 180. So what does that angle measure there?
Um. 60.
60. So this is 60, but we want angle 1. We know that angle 1 plus this one we just found plus this, what does this symbol mean here?
90 degrees.
9 degrees. So we have this unknown one, measure of angle 1 plus 60 plus 90 equals 180. So you have the measure
Mhm.
of angle 1 plus 150 equals 180. Measure of angle 1 equals 30. It asks in number 4, it asks for the measure of angle 2.
Mhm.
So let me actually just snip in the same picture, and we'll just go at it differently for this next one. So going down this direction, this arrow right here, this is also 60 degrees because they have to add up to 180. This is a isosceles triangle, which means that the base angles, this is a base angle, and so is the 60-degree angle, that they have to be the same. So the one I'm pointing at is 60 degrees, and then they want angle 2 here. Well, these two have to add up to 180, which means the measure of angle 1 is 120. Oops, sorry.
Oh, okay.
Measure of angle 2 is 120 degrees. I know that I guess they sort of match up there. It's letter F. All right. Okay, we'll move on to number 5. Okay, so the one way to do this is to draw two triangles. Another way is to match up where L is, or where I'm sorry, where T is. So T is the first letter, so it corresponds to the first letter there. That means that it has to be PK. So like angle G and angle E are the same, angle S, angle L are the same. And then you can also do this with sides as well. We talked about that a lot last week. We could certainly do that again this week if we need to. I can move on to question 6 though also.
Oh, I understand.
Okay. All right. So this one, these are tough because they're multiple choice. There is a mistake here of getting the wrong ordering of the triangles. So because these are parallel lines, these two angles are congruent. And there is enough here to prove that this top triangle is congruent to this bottom triangle, but the order does matter. Okay,
Yeah.
so like M and G have to correspond. So see how like M and G don't correspond in their order here. This last one, we know that that's out.
Yeah.
But M and G correspond in all the other ones. So okay, that doesn't help much. N is the one that corresponds to H.
Yeah.
So we're looking for like an H and an N in the same place. So this one is out. And then here, this one is out as well. So let's just check that this works here. So H to M to N and back corresponds to N to G to H to N. So H to M to N, it starts here, goes to the 90. Well, N to G also goes to the 90. And then M to N goes to the other side, G to the H goes to the other side. So that's why G is correct. So you're matching the letters. All right, moving on to number 7. Rhombus QRST is made of two congruent isosceles triangles. Given the measure of angle Q to R to S, Q to R to S, so that's this whole thing, is 34 degrees. Okay. What is the measure of angle S? So there's a lot that goes into this. You have to realize that this angle right here and this angle right here, they are congruent. So it's not a good idea to do this, but it is okay to sometimes assume that they are. So they're each 17. And because this is an isosceles triangle down here, that means that this base angle is the same as this base angle. So this is also 17 degrees. So if they're both 17 degrees, they add up to 17 plus 17 plus S has to equal 180. So when you solve that for S is 146 degrees. All right. Can we move on to 8? Is that okay?
Mhm.
Great. 8 really requires you to graph it, which I don't know how they expect you to do that on this little, so your teacher could print out these this PDF they sent you. I just don't understand how you're supposed to do it with uh, otherwise. But let me see if I can get the axes here reasonable. So let's go with that's the origin. So A is 2, 0, B is 5, 0, and C is 2, 6. 2, 3, 4, 5. So up here somewhere. So here's your triangle. That's A, B, C. Okay. And then D is -6, -7. So that's pretty far over here. That's what, 1, 2, 3, 4, 5, 6. And then down 7, 1, 2, 3, 4, 5, 6. And then we're going to go down one more. I don't even know if I got that. Yeah, right there. And then E is -3, -7. So -3, -7. And then F is -6, -1. So there's your triangle. It's pretty helpful to do this. What do you see here? Like how do you get from, I maybe didn't go down. Let's see, 1, 2, 3, 4, 5, 6. So it's actually this one. But how do you go from this to this? What do you say?
Translation.
So the options are, let me read them again here. Flip, rotation, reflection, and translation. So there's actually two translations. There's one left and one down. So I would say, yeah, J is correct on that one. All right. Number nine. So do you recall? There's 4. They should have been 4 in class that they explained were satisfactory for proving congruent triangles, and they are all here. One of the things that I think is challenging here is when they're sort of overlapping each other. So what I would do is I would actually draw them separately: ABE, ABE, and then FDC. So like what I see is that this side is congruent to this side. I'm just drawing on those right there. And then these are congruent to this. And then because these two lines are parallel, you can show that this angle is congruent to this angle. So that's this angle and this angle. So you got side, angle, side on this one, side, angle, side on this one.
Wait, it's side, angle, side.
Yeah, side, angle, side on this one. Is there something maybe did you get, is that clear, or do you want me to go through that again?
I'm just like confused on how to like which one's which. Like I don't think my teacher did a clear job of like explaining which one's which.
Okay, so let's talk about side, side, side. So here's triangle A, B, C, and here's triangle D, E, F. So for side, 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 you have to have one side congruent to another side congruent to another side, and then a third side congruent to another third side. I think that one's pretty straightforward. So then the one we just did, it comes in so many different forms, side, angle, side. So there's a lot of ways we can draw it. So for example, let's say we're focusing on this angle being congruent to this angle. So we need this side congruent to this side with one mark, this side congruent to this side with another mark. But let's say you wanted to see, you somehow had this angle was congruent to this angle. Well, then you would have to show that this side over here is congruent to this side over here. And then similarly with these other ones. There also, there's other things that can happen here, like they don't have to necessarily be oriented the same. Like it could be that this angle is congruent to this angle, but the side over here is congruent to the side over here. So the left could be the right, and then here the right could be the left. And there's a lot of other variations like that. So it would be good to go through them all, but it would take up a lot of our time. So,
Okay.
I'm not sure. It does look like I'm just sort of looking ahead here. It looks like question through these. Some of these questions are the same. Oh, there they are. Okay. I see. Now let's go to angle, side, angle. Maybe this will make some more sense. Angle, side, angle. So we have a triangle and a triangle. So let's say this angle is congruent to this angle. This angle is congruent to this angle. Well, the side, it has to be between the angles. So that means it has to be this side congruent to this side. So let's do another example. Let's say that this angle is congruent to this angle over here, and this angle is congruent to this angle over here. If this side is congruent to this side, this is not angle, side, angle, because the side has to be between the angles. So it has to be that this one with the double line is the one that makes it work. So let me maybe generalize this to help. I don't know if this will help or not, but this is an angle, this is a side, this is an angle, this is a side, this is an angle, this is a side. When you're talking about side, 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 obviously it's the three sides. Okay. Side, angle, side, you have to choose the angle between them. It's not as if I can choose this side, and another angle. There has to be this sort of path where side intersects with an angle, intersects with the side. Then angle, side, angle, same thing. You have to start at an angle, move to a side, get to the angle. The side has to be between there. So this angle goes with this side, goes with this angle. This angle goes with this side, goes with this angle. And then the last one, angle, angle, side, you have to move from an angle to an angle to a side, or an angle to a side, or this angle to this angle to this side. The side is not between them in this last case. We can do some more examples of those, but let's finish going through this the rest of this, so that you at least have all of this available to you.
Okay.
So what they're doing in this problem is they're giving you a proof, They're giving you all the statements, they're giving you the reasons, but they're saying, hey, you need to fill in what number 4 is. So you can go through all the proof steps if you want, but it's telling you that they're proving the triangles are congruent. So there's really only 4 options: side, 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 angle, or angle, angle, side. So let's see what we've got here. We're proving triangle EGA, E to G to A, is congruent to I to A to G. This is another example of when it's really good to separate the triangles. There's extra lines that could just be distracting. So this is EGA. And then over here, this is GAI. And then you just draw in the stuff that's already given. So like E to G is congruent to I to A. Okay. This angle down here is congruent to this angle over here. And later on, you prove that this side is congruent to this side. So just looking at the picture of the triangles, you see a side, an angle, and a side. A side, an angle, and a side. So that one is the best choice there. Now, this next step here, this number 5, it almost always follows a congruent triangle step, congruent triangle statement. And you probably heard this in class or saw this. It's all these letters: CP, CTC. And that's short for corresponding parts of congruent triangles are congruent. I hope you've seen that.
Yeah, I have.
Okay. And this it almost always follows. Like you don't have to, I don't want to trivialize this too much, but I mean like it's literally like if you prove the triangles are congruent and then you prove this step 5 here, you could be proving angles or sides, and it's always CP CTC. It always follows this congruent step. Oh, and there they are. I didn't realize they had them down there for 10 and 11. Okay, let's go to 12. What is the classification of a triangle by its sides? We're going to graph this one. Are you going in? Is it in person tomorrow, or is it virtual again?
It's virtual tomorrow.
Okay. I would have some graph paper around if they'll allow it. If they don't allow it, you can always graph these on Desmos. Do you know how to do that? Would you like me to show you how to do that?
Oh, I know how to do that.
Okay. So I'll do it here. -3, -1, -2, +2, and 3, 1 there. So nothing kind of obvious from it. If you draw this really well, kind of looks like it might be a right triangle. Might be. We're not sure.
Mm-hmm.
Can you eliminate any of these though? Any of these 4? Just from sort of looking at it.
Collateral.
I agree. That's definitely out. Isosceles is probably out. But what it really comes down to is like, is this right here perpendicular to this right here? So we had A, B, and C. We need to find the slope from A to B. Now, if you've got it graphed, it's rise over run. It's 3 over 1. You can always use the slope formula. Okay. From B to C, you're going down 1. And then how many are you going right? Well, 1, 2, 3, 4, 5. So you're down 1/5. So the way you tell if those are perpendicular is that you see, does the product of them, does the product of those slopes equal -1? So if slope 1 times slope 2 equals -1, they're then perpendicular. Do these two multiply together to give you -1? No. So it's not right. So that was incorrect, but it sort of looked like it. So we can say that the right one is out. It's isosceles if two of the three have the same length. I think you can visually see that that doesn't happen here.
Mm-hmm.
So that one is out as well. So it must be scalene. You generally want to keep from having to use the distance formula here. You could do the distance formula on each one, but if you're willing to make a reasonable sketch, you can get pretty close to the visually seeing what it is.
Mm-hmm.
All right, can we move on to 13?
Yeah.
All right. Well, this one isn't particularly. You'll see that the solution is not. It's sort of given from these answers. They're wanting this coordinate up here. We know that it goes along the y-axis, so we know that it must be 0 comma something. Well, the only one that is this right here. There would be more needed to give you a reason for that. So I'm not. It seems like this is not a great question for you.
Mm-hmm.
I'm not sure why. So what one thing you could do here is you could pick a value for a that made sense for you, like I don't know, 3. So if this is your origin, and you go out 3 and you go out 3, and you don't know how far you go up here, but you know that these have to be the same. Well, um, there's well, I I guess they really want you to they're just asking you to point to this answer, because really it could be as tall as you wanted if these sides are the same. Like you could draw a little triangle like this, and these are still the same, or you could go up a lot taller and they're still congruent. Um, so I don't know that I can give you much more information on that. Do you want us to go through the bonus?
That'd be great if you could.
Okay. Um, One of the things that is a little bit hard to see are the numbers, because you have two parallel lines here. This first one is a transversal. That means that this angle is congruent to this angle. And this one is this one right here. And this one I'm circling is this one down there. So since they're alternate interior angles, because these are parallel, this is a transversal that cuts it, so they're congruent, you can just
Mm-hmm.
set them equal to each other. 2x plus 51 equal to 43 minus 2x. All right. So if you don't mind, will you go ahead and solve that for me, please?
2x plus 51. That one.
Yes, I'll be right back.
Okay.
All right, I'm back. Did you get to solving that?
Yeah, I'm almost done. I got -2.
Great, that's the same value that I have here.
Okay.
We should check it, but you'll find that if you check it in 5x plus 60 equals 30 minus 10x, they're this for the same reason they are congruent. It's a different transversal, but this angle is congruent to this angle, which is how we get down to these equations down here. And if you solve these, you end up getting the same thing. You get x equals -2. It looks like we've completed everything here.
Yes, we did.
Would it be at all possible to stop here?
Yes.
All right, I will send these notes out to you within about 10 or 15 minutes, and the video recording as well.
Okay, thank you.
All right, thanks, Julia. Bye now.
Thank you. Bye.